In this experience, we focus on observing the hysteresis loop of an iron rod. The equipment we need is shown on the desk, and two solenoids, two Gauss meters, and a power supply, a breadboard, some alligator wires, and an whole IC. The property of an iron rod is that when we place it in a magnetic field of one direction, it will be magnetized. However, it won't keep increasing its strength of magnetic field as we increase the magnetic field applied. The fact is that it will finally stop at a constant value, which is called the saturation point. On the other hand, when we apply an opposite direction of magnetic field, it will be demagnetized and similarly reach another opposite saturation point at the end. This loop of magnetization and demagnetization of an iron rod is called the hysteresis loop. And in this experiment, we will use two separate circuits for it. One is used to create magnetic field applied on an iron rod, which is given by these two solenoids. Another is given by the Gauss meter, which is used to detect the magnetic field caused by the solenoids. And this is the Gauss meters. And we will utilize the property that an whole IC will create a whole voltage when the applied magnetic field is perpendicular to the current flowing through it. And for this experience, we will divide it into two parts. In the first part of the experience, we would like to sweep the magnetic field with the solenoids and detect the magnetic field with the Gauss meter. And in the second part of the experience, we will keep an iron rod inside one of the solenoids and detect the magnetic field again with the Gauss meter, and the magnetic field detect in this experiment is the combination of the solenoids and the iron rod. Therefore, in order to find the whole voltage caused by the iron rod, we needed to subtract both the whole voltage from the first and the second experience, and eventually we will obtain the hysteresis loop of the iron rod alone.
Now we are going to talk about the setup of our first experiment, which is obtaining the relationship between the magnetic field and the current applied to the solenoid. So now, to obtain that, we have to first set up a measurement tool to measure the magnetic field applied from the solenoids. So now I'm going to talk about how to use our power supply. Okay, so the power supply consists of two modes, which is the constant voltage mode. You can see it right there, it's the red light, and the constant voltage mode. And well, as the word shows, when in the constant current mode, the whole circuit connected to the power supply will have the same current throughout the whole circuit. And for the constant voltage, it is the same. Yeah, so vice versa. Okay. Okay, in order to achieve the constant voltage mode, we have to firstly apply high enough voltage. Then we have to firstly apply the high enough voltage in order for the whole circuit, for the whole loop, to have the same current, because that's how the current will flow through the whole loop with the same current. And for the constant voltage mode, you have to apply high enough current that you can see there. Then it will enter the constant voltage mode, like this. Okay, now I'm going to talk about how the whole IC work, and not how it works, it's how it will be functional, like how we have to connect the power supply to it. Okay, so this is the source terminal, which we will apply our power source and our multimeter source to this terminal. And this is the ground terminal, which we will connect our power supply to this terminal in order to supply the whole IC with power for it to be working. Okay, so the third terminal here is the output terminal. This terminal with the source terminal will output the corresponding magnetic field, well, the whole voltage caused by the magnetic field through the output terminal. Okay, so now I will connect the circuit to the breadboard that I've set up before. Yeah. So as you can see right here, with the multimeter having numbers here, and we can use the magnet to check if the whole IC works, because when we have a higher magnitude of the magnetic field applied to the whole IC, you can see the voltage caused by the magnetic field will increase the output voltage of the whole IC. Or sometimes, yeah, okay. So now, in order to measure the a moment. 怪怪的。Okay, in order to measure how the magnetic field produced by a solenoid, we have to firstly put the whole IC in between those two solenoids in order for it to detect the magnetic field generated by the solenoids. And now I'm going to, as you can see right here, I'm going to apply some voltage or current to the solenoid in order for it to generate some magnetic field. You can see right here. So now supposedly the whole IC should have some change in the magnitude of the voltage due to the generation of the magnetic field, but we have to place the whole IC in the correct position for it to be more obvious, but the distance, I guess, is too far for it to be noticeable. So I can only tell you the principle of it instead of actually performing it. So yeah, then we can put the voltage applied to the solenoid will correspond to the magnetic field generated by the solenoid coils. Therefore, we can use it in our x-axis. Then we can use the change in whole IC, the whole voltage, as the y-axis in order to see the changes, in order to see the relationship between the magnetic field and the whole IC voltage. So this will be our first experiment. Okay.
For the second part of our experience, we want to find out the hysteresis loop of this iron rod. And to reach this purpose, we will perform. We first need to make this iron rod be demagnetized. And to demagnetize this iron rod, we have several ways. And the one we use is to heat it with a burner or a lighter, and utilize the app on the phone to detect it whether it has the low value of its original magnetic field. And after the magnetization of the iron rod, we can place it in one of the solenoids as we mentioned before, and to measure and we can find out the relationship of between the whole voltage and the applied magnetic field. And we have two methods to do this. One is that we utilize the two solenoids in the same direction as this, and we can obtain the result that the magnetic field is the combination of two solenoids and the iron rod. And after obtaining this result, we can subtract the result from the first experiment, which that the magnetic field is only caused by the two solenoids. And after subtract the first experiment results, we can obtain the magnetic field caused by the iron rod alone. And the second method is that we switch one of the solenoids into the opposite direction of the original direction, and after doing this, we need to make sure that we can utilize some app to measure the point that the magnetic field is actually zero, and put the whole IC at the point to detect the magnetic field caused by the iron rod. And why we should doing this is that the magnetic field caused by the magnetic field detect in this way will only be created by only the iron rod, but instead of two solenoids. And this is all of our experience. Thank you.
Okay, so now we are going to take a look at the experimental result of this semester of our experiment group, the hysteresis loop. And now we can see that on the yellow line, due to the fact that the iron rod was properly demagnetized, it starts from the origin to the saturation point. You can see right here, and you can see on the saturation points, it actually shows a line that the magnetization no longer takes an effect that increase the voltage of the iron rod. Okay, so now we are going to lower the current of the coil. You can see that even though the current of the coil was cut off, there are still certain remaining of the magnetization. You can see the gap right here. And now we can change the direction of the coil, and it will reach a certain negative saturation point. You can see right here. And now we can turn off the current of the coil. You can see there are still some remaining right here, and notice that those two gapping on the remainings are almost the same. It is due to the fact that the molecule of the iron rod haven't changed. Therefore, the magnetization remaining will still be the same. Okay, and then we can apply the current again. It will still reach a certain saturation point, and creates a loop is called a hysteresis loop. Okay, now let's look at the other groups. So now we can see that on this graph, the point of the hysteresis loop was actually showed up, but not very clearly. You can see that there are still some saturation point right here and the negative saturation points, and we can suppose that this is the origin. Therefore, when the current was cut off, there are still some remaining. Okay, now next group. Okay, for this group, you can see there are some stair-like cases, figures of those points. We can assume that this is due to the fact that the scaling of their measurement was incorrect, therefore making it like a stair. But we can still see that it showed the saturation points like right here and right here, and there are still some remainings. Okay, on this group, we can see that the measurement points, they showed up, formed almost two lines on the positive region and the negative region. And we guess the reason that this happened is due to the fact that their choice of graphing on the choice of scaling on those graphics are not correct, maybe too large. Therefore, the lines were all clumped together, forming those horizontal lines on this graph. And it is quite unclear on the colors too. Okay, now next group. For this group, the graph is actually beautiful and almost perfect, but and the magnetization was complete. You can see right here, and it also reached two saturation points, show the remains. But however, we cannot see the whole process from the colors that they chose, because there's no other colors other than blue that's being chosen. Therefore, we cannot see the whole process, but the graph is good. Okay, now this is the last we are going to see. You can see right here, it too reached the saturation point, like right here and right here. And those remains are really small but still exist. But however, we can observe that maybe there's a lack of a line that they didn't conduct. You can see right here that actually didn't close up the hysteresis loop. But however, it is still finished whatsoever. Therefore, we can call it a great result. Okay, so now this is going to be the total review of the experiments that we are responsible of for this semester. Thank you very much.